Alright, welcome to Tolfson Physics. So what we're going to do today is we're going to play around with what's called a Van de Graaff generator. And so what this Van de Graaff generator does is it has this little belt in here made out of a plastic type material, and it actually rubs against something both down below and up above, and that rubbing causes the transfer of electrons. And so this globe is going to get charged. So just to demonstrate, I'm going to turn this on for just a moment, create a charge, and to prove there's a charge on there, I'm going to bring my hand near. Oh, you hear that spark, right? So what happened is I created an excess of charge here, and once I got close enough, because the air is an insulator, once I got close enough, the electrons were able to jump. And so that's what that little spark is. So in some respects, this is what happens with lightning. Clouds gain an excess charge. Now, clouds are far apart from the ground, so you need a humongous charge, but eventually the electrons are going to try to jump and become more neutral than it was before, so spread the charge out more. So we're going to do some experiments to see what's going on with this. So if you remember, we did play around with sticky tape, right? I took two pieces of tape, which I'm going to do right now. Take one piece of tape there, put it down for a second, take a second piece of tape, and I'm actually going to go ahead and make sure I write which piece of tape that is so that I know what I'm looking at. And if you remember from our experiments before, the top tape, so the one I just wrote a T on, the top tape is going to be the one that is positively charged. And so what I'm doing here is I'm basically pulling these apart so that there's more electrons on the bottom tape than there are on the top tape. Now remember, when I add up the number of electrons and protons on both tapes, they're equal. But right now I have more electrons on this tape, which means I have more electron holes, so positive charge on the top tape. And we can prove that they attract, they're attracting to my hand right now, but watch up, see they attract to each other, then they attract to my hand. There, they attract to each other, keep attracting to my hand. Alright, so what we're going to do is I'm going to put that off to the side for a moment, and we're going to use that to help figure out what's the charge on the Van de Graaff generator. And so I'm going to charge it up again, because I touched it, so I neutralized it. So now I'm going to charge it up again. So it's charged up, and now what I'm going to do is I'm actually going to take my top tape, I'm going to put it on a rod so I can bring it close, and I'm going to start bringing it close to the Van de Graaff. Oh, and look at that. Oh, and I got sparked. But, oh, there's still some charge. So notice that the top tape is being attracted to that. So what charge does that make of that? Positive here, attract, so that means that is a negative charge up there. So, you know, we could test that with the other tape too. See, the other tape is a negative tape. So what should happen? Well, this should go away from it, repel. So bring it close there. In fact, it does. See how it's going away from that? So this has an electric field. So think about that like a gravitational field. So you don't have to be standing on the ground to feel the pull of the earth. So if you're off the ground, falling through the sky, you jump off of something, the force due to gravity is still pulling you down towards the center of the earth. Same thing is true here, right? So the difference though is, look at this. I can not only attract, I can repel. And I don't have to touch that metal sphere to get it to repel. Look at how far away. I'm a couple inches away, and it's still being repelled. So this is a different type of force field. So we have a gravitational field that we learned about before, and now we have an electric field. Now we can see what happens with charged particles. So let me put that over there. Hopefully it doesn't lose charge. And let me just neutralize that for a second so I know it's neutral again. And actually, I'm going to have myself touch something metal to make sure I'm neutral too. And we're going to do our first experiment. And so our first experiment is I'm going to take a pie pan, and I'm going to touch it to this when it's charged. And then I want to see what the charge on this is. I bet you can probably predict that ahead of time, but let's see what the the experimental result is. So this will be negative. What will this be? Let's find out. So this is called charging by conduction. Turn it on, turn it off, and then as I bring this close, you might hear a spark. Oh, yep. But I actually want to touch it, make sure it's got a good charge on here, and then I'm going to pull it away, and then I'm going to go ahead and take, oh, see, it jumped a little bit to me, so I have a little bit of charge. Now I don't. So I'm going to take the top tape, and hopefully it still has a charge. It does. Look at that, right? Look at that. It's, attracted to this. It's attracted to this. That should kind of make sense, right? So if I have a whole bunch of excess electrons on there, and I give it some more metal, which is a conductor, for it to spread out further, right? Electrons repel electrons. So they repel and push some of them into my pie plate. And so this is now negative. So I'm being kind of careful because I want to grab this over here. This should be neutral. And if I touch this sink, that's how I know it's neutral. Touching something like the metal on your sink is called grounding it. And what does that actually mean? Well, the pipes eventually enter the ground somewhere. And so what does that mean? Well, the ground actually is a great source or sink of electrons. And so the ground is neutral. And so if I have excess electrons, they're going to just go into the ground. If I have not enough electrons, well, it's going to give me electrons to make it neutral. And so all of your homes have a ground to them. So at your electric box, there's usually a big copper wire that might be attached to your plumbing, or it might just have like a 6-foot rod pounded into the ground right outside your house, and it's attached to that, literally pounded into the ground. So that's where that comes from. Okay, so this was the first experiment that's actually in your worksheet packet. So when I touched it, this becomes negative. This, I just neutralized. What happens when I touch these together? What happens when those are touched together? Okay, so I've touched them together. Now I'm going to let go. And I'm going to grab my tape. And let's find out what happens to the tape. Okay, look at it. It's being attracted. It's being attracted. It's flying towards that. So positive, negative. That makes more sense. Now it doesn't seem like it's doing it as strongly as it did before. And then what about the pie plate that I started with? Well, let's find out. Okay, it still attracts. It should. Because what did I end up doing? This had a whole bunch of electrons on it. And then I put something that was the same, touched it. So guess what the electrons did? They spread out as far as possible. So, let's say I had 100 extra electrons on this plate. After I touch them, I got 50 on this plate and 50 on that plate. So they spread out evenly because they repel each other and they want to get as far away from each other as possible. All right, so that's the first set of experiments, charging by conduction. So now what I'm going to do is I'm going to touch these to the sink. Now they're neutral. All right, I want them to be neutral for my next experiment. So I'm going to start off neutral, and let's make sure this is neutral, just so we know where we're starting. Let's make sure I'm neutral. Okay, so now we're going to do something different, and this is called charging by conduction. I actually need both of these pie pans for it. And what I'm going to do is I'm going to charge this, and then I'm going to bring my 2 pie pans close to it without touching. And hopefully it doesn't spark, because if it sparks, that means the electrons jumped. I don't want the electrons to jump. I just want it to be next to the electric field and then see what happens without touching. Let's find out. So let's turn this on. Whoa. I heard it's sparking. I can hear it sparking. It's a low humidity day, and so the electric charge actually can build up quite a bit. I heard it spark again. So what I'm going to do is I'm going to try to bring this close without getting it to spark. Let's try there. And then I'm going to bring this pan. I'm going to touch the other pan. Okay. And then I'm going to take this pan away while I'm still close. And I'm going to take this pan away. And let's find out. So I'm going to put that far pan far away so it doesn't influence anything. And let's find out what the charge on this is. So let's hope my tape still has charge, because they do lose charge. They do lose charge over time. And let's bring it close. And so this is positive. Oh, look at that. It's repelling. See how I'm moving my tape as I bring this closer? This became positive. That's negative. This is positive. Okay? So I can actually get the opposite charge by not touching it. But I did it in a special way. So this one that's close by is positive. Let me grab the other one without touching it, because if I touch it, I'll change its electric nature. Now let's bring this nearby. See what happens. It's loose. There it goes. You can see it now. It's attracting. Oop, and I just got too close to that. But it's attracting. That means this is a negative charge. This is a negative charge. So let's think about what we did. This is a big negative charge right here. Whoa, I felt it. You can hear it. Okay, let's get rid of the charge so I don't zap myself a million times. This is a negative charge. I brought this nearby without touching it. So when this is just sitting here without touching it, if this has a big negative charge, where do the electrons want to go? Well, they want to get as far away from this as possible. So this is neutral. But the electrons on this side are like, I can move. This is a metal. It's a conductor. I'm going to go over there. So the electrons gather on this side. There's more electrons on this side versus this side because this is a huge negative charge. Well, then what happens when I add a second pi plate? Well, those electrons are like, I can get further away. And so they go into this pi pan instead. And it leaves an excess of positive charge in this pi pan. And so when I'm next to an electric field and I pull this pi pan away, those electrons don't have the ability to go back because I just took them away. And what does that leave here? It leaves a positive charge. The overall charge, if I take this pi pan plus this pi pan together, it's actually neutral, right? I have the same amount of electrons here as electron holes here, which gives me a positive charge. Right? The electron's got to go somewhere. It's conservation of charge. Okay, I'm going to show you one more way. I'm going to create a charge without touching again, but only with one pi plate this time. How are you going to do that? This is neutral. Let's make sure it's neutral. Let's make sure it's neutral. How am I going to do that? Well, let's show you. So let's turn this on again. Okay, just get a little charge on there. Hold it nearby without sparking. Okay, and I'm going to go ahead and touch this pan. I felt a little spark. Oh, I just heard a spark. Hopefully that doesn't change our result. All right, so I have this nearby. I'm touching it. I'm going to remove my hand. Now my hand is acting like a ground. So either electrons can come into me or I can give electrons. All right, so think about that. So let's get the top tape, which is a positive tape again, and let's bring it nearby and see what happens. Okay, and I think I'm starting to lose my charge, but notice that it is repelling ever so slightly. I might have to make new tape. Let's try the bottom tape. The bottom tape, if that's repelling, should attract. So let's find out. Does it attract? Yeah, it absolutely attracts. Okay, so this is a negative charge. And so what does that suggest? This has a positive charge on it. Like I said, the tape loses charge over time. Every time I stick it to the sink, the electrons can go to the ground. Now, they're insulators, so it's hard for them to do that, but they do it over time. So anyway, this is positive, just like before. So how does that happen? Well, negative charge again, right? Negative charge here, neutral here. Electrons, once again, want to get as far away as possible. So what's their solution? Me. I'm the ground in this case. So the electrons jump into my hand, into my body. And so when I let go, I keep the electrons with me, and that leaves a positive charge on the pi plate. There you go. So charging by conduction, touching this, gives us the same charge that's here before. Ooh, it's still charged. So it gives us the same charge that we had before. But charging by induction, right, not touching, but allowing the electrons to go somewhere else, gives us the opposite charge. All right. One more experiment that we're going to do, and actually, there's a similar experiment in our packet. But what that experiment is, it actually in the packet has a person that's hanging. So a person is hanging from a rope. And then there's a lightning rod. So here's our lightning rod. And so the lightning rod, the lightning strikes it, it has a big charge. And in this case, negative charge. So this is neutral. The person's neutral. What happens when you have something negative and something neutral? Think about that. Think about that. Okay? And then what happens if this collides with this? What happens to the charge? And then what happens because this has the same charge as that? And then also in that problem, and I'm going to use this, I'm going to be the ground, although I'm going to use this in between. And this will be held here, and this has the ability to come back and touch the ground. So what happens then? All right? So we're going to see how this works out today. Turn it on just a little bit. I'm going to hold this right about here. Oh, you can hear spark. Okay, let's see if it's going to start going. There we go. Oh, wow, look at that. So it's going back and forth, back and forth, back and forth, back and forth. Right? What's happening? Neutral is attracted by a charge. So in this case, negative charge. Once it touches it, guess what the neutral becomes? It becomes a negative charge. So it's repelled from the negative charge. Okay. And then it comes over to the pi plane, which is the ground. And so that extra charge goes into the ground. Once it's neutral, it goes back. And it repeats the cycle, right? Becomes negative, repels, becomes neutral, attracts, so on and so forth. And you notice it eventually stopped. So why did it stop? Because there's no charge left on here. I took all the charge out by it going back and forth. All right? So you can actually see a lot of what's going on at the subatomic level by looking at these kind of things and how charges are attracted and repelled to be able to see what's going on at that subatomic level. All right? So hope you enjoyed this and keep on physicsing.